the whole biodiversity conversation around GMOs need a bit of redirection, where then we're asking the question, I think, how can GMOs play a role in helping improve upon biodiversity?
Welcome to the Case for Conservation podcast. I'm your host, Andre Mada. Few technologies are viewed with as much suspicion as genetic modification. Genetically modified organisms, GMOs, are banned in several parts of the world. An entire protocol under the Convention on Biological Diversity, CBD, is dedicated to controlling their effects on biodiversity, and national and international agreements and regulations tightly legislate their use across a broad range of applications. Why then do GMOs continue to grow in popularity? Why do farmers in the developing world consider them game-changing tools to deal with the demands of making a living or even a livelihood from agriculture? And what's all the subversive business about GMOs being good for biodiversity? Joseph Opoku Gakpo is an environmental journalist who writes about GMOs and other aspects of agriculture, the environment, and rural development. He is Ghana correspondent for Alliance for Science and was awarded the Ghana Journalists Association Prize for Best Journalist in Poverty Alleviation Reporting in 2015. Joseph has a passion for sharing the struggle of farmers and other rural people, which is reflected in his refreshingly clear and level-headed style of reporting. In this illuminating discussion, we talk about how GMOs got such a bad name, whether any of the allegations against them are justified, what they mean for poor people around the world, and what is the nature of their relationship with biodiversity. I started by asking Joseph to just begin with basics and briefly explain what genetically modified organisms are.
Essentially, GMOs are crops where their genetic component has actually been modified to a certain extent or altered by virtue of the introduction of genes from other species into this specific species. So for God knows how many years now, there's been deliberate efforts to improve upon crops. And it's mainly been through what is referred to as the conventional plant breeding processes, where on the field, you cross maybe a corn that has an improved trait, maybe it's more climate resilient with one which isn't, and then introduce the traits. But when it comes to genetic modification, then what the scientists do is to use a laboratory procedure to then identify the specific gene that is responsible for that desired trait, maybe climate resilient, maybe drought resistant, and then use the laboratory procedures to then introduce it into a specific crop of interest. And sometimes that happens across species where it's possible to then, for example, isolate a gene from a bacteria and introduce it into corn, which is a plant. And so that happens. Essentially, that's what genetic modification and GMOs are. And so products that then result from some of these laboratory processes are what are then described as GMOs.
Okay, yeah. And you mentioned that it can be across species and across very distantly related species, right? Like a bacterium and a crop are very, very different genetically, and yet this technology allows them to be combined in a certain sense. And I get, my next question was going to be about why are GMO crops controversial? And I guess that kind of you've partly answered the question already, because I think that just the idea of something so alien and so unusual as to combine completely different forms of life. Perhaps that's the reason. But do you have any other kind of insights on why GMO crops are so controversial and why they've been controversial for such a long time?
Yeah, but this point about moving genes across species, from a lot of scientific work as we've come to know it, all living organisms are made up of the same very basic structures. And so it's only just how they are arranged that differs. That's how come some look like animals, some look like plants, some look like humans. But in terms of the very basic forming blocks, all living things have the same thing. And the scientists have attempted characterizing it. For anyone who may have taken a basic genomes course, you'd have heard what is described as the A gene, the C, and the T, which are representations of the basic building blocks of all living organisms.
Mm-hmm.
They are the same. That's how come it's possible to move genes across species, although you may be dealing with animals and other related species. So to a certain extent, I think that's part of how come GMOs are seen as controversial.
Mm-hmm.
But I have one additional very interesting theory of why I think they are controversial. I think they are mainly controversial by virtue of how they got introduced in the early 90s, in the late 80s, and how the technology came to be popularized. And I'm not picking on any industry at this juncture. I have very good respect for industry and all. But the company that dominated the GMO space in the early 90s, Monsanto, which has been taken over by Bayer, had an interesting reputation around then. And I've dug into this a bit. I did a course in agricultural biotechnology, a BS in agricultural biotechnology at the Kwame Nkrumah University of Science and Technology here in Ghana. And so it's one of the things that we focused on. This is a company that used to be dealing mainly in insecticides. They've been linked with some very controversial stuff, including pioneering the sale of products like the BBT, which was used for a very long time in agriculture, but then at a point in time was considered to be very damaging to the environment. They were involved in what was described in the 60s and 70s as the Agent Orange herbicide, which to a certain extent, the US military played a role in having used that in their warfare in Vietnam and all. So the company had been involved in controversial stuff. And then in the late 80s, in the early 90s, then they were then transitioning from being a chemical company into a biotechnology company. So then a certain hatred had been built towards them even before they transition into dealing in GMOs. And then they also made what I think were some very controversial decisions, including patenting and all with their products. And so then that then kind of created that whole furor around the work that they do. And I think how they led some of those processes, them being the company that led some of those processes with the introduction of GMOs and popularizing it after their very controversial history, is what has built a certain negative perception of the technology. And so today, everyone tends to assume anything GMO is Monsanto related. The company has been taken over by Bayer, but still all of that exists. And I think that's where a lot of the problem was to a certain extent. That if all of that if they didn't have a very controversial history, maybe the technology would have had criticisms here and there, but it wouldn't have been as huge as it is currently.
That was kind of, well, let me just ask, first of all, was it introduced kind of globally at the same time, or was it first in Europe and then later in Africa and Asia? Do you have any idea of how the sequence of events went as far as the geography is concerned?
So it was actually mainly introduced in the USA.
All right. Because Monsanto is American, right?
Yes. So Monsanto is an American company. And I think about 5 years ago, then it got bought up by Bayer, which is headquartered in Germany, but then it's a global firm. So it first got introduced in the mid-90s in the USA, where the first GM crop was commercialized, and then subsequently spread to Latin America. And then conversations began around introducing it in Europe. Europe has had a very tight process in terms of approving GMOs. So GMOs are not as popular in Europe as they are in America.
Right.
And then we then saw the spread to the developing world, including places like the Philippines, Bangladesh, and then places like Africa as well. So essentially, that's how it's been over the last few years.
So you've sort of spoken about why they are controversial, but can you tell me why you think they shouldn't be considered controversial?
Yeah. I think it's one of the tools that can be used to improve upon crops. And so it shouldn't be shunned. It shouldn't be taken out of the toolbox, if you could put it so. There have been other processes in terms of trying to improve upon crops. Conventional plant breeding processes have been used where the crossing and the moving of the traits is done on the field. Agriculture itself began as what is described as hunting and gathering, where people went around and then picked up on already developed crops and did trial and error as to whether they would die when they consume it or otherwise. And then they preserved what kept them alive after they had consumed them. Then agriculture moved into a very different phase where then humans domesticated the plants, where we deliberately grow the plants and then they reproduce and then we consume them. Then as the population grew, then we got to the stage where there was a lot of movement. So we grow crops on the field, the soil gets depleted, then we move to another place to go plant the same crops. So there's been all of these efforts at developing agriculture. Then we got to the conventional plant improvement methods. Then we got to the use of fertilizers and all and pesticides. Then we veered into what I think is a new area of keeping up with technological improvement as a way of helping deal with food security challenges. And I think the GMO technology has shown that it could be a force for good if appropriately applied. And that's why I think it shouldn't be shunned.
Right. But there are, I remember hearing that they might be bad for human health. I remember also hearing that there was the possibility of contamination of other crops by GMO crops, and then together with that, this whole idea of the terminator genes, where the seeds of GMO plants are sterile. So those are three things that come to mind of the risks and the kind of the specifically practical reasons why there was resistance to GMOs. But are any of those justified, or are they exaggerated?
Just to make a point, clearly there's been a deliberate disinformation campaign targeted at GMO specifically, which I think part of it has been from folks in the spaces that kind of feel threatened with the introduction of GMOs. So then deliberately target the technology with some form of disinformation as a way to then keep it out of people's homes and discourage people from consuming them. I get the sense a lot of that is happening. And not just that, we've seen situations where in certain parts of the world, for very economic reasons, and as part of what I think has been a conscious effort to protect specific markets from American produce, because then this is American technology and this is American food to a certain extent. Then there's been the effort to as well create disaffection for GMOs, which sometimes fuel some of these disinformation campaigns. On the health bits, there was a major study that was recently commissioned by the National Academy of Science, Engineering, and Medicine in the United States, which looked at data from when GMOs were introduced. And that specifically concluded that in terms of negative health consequences, there is zero evidence linking the consumption of GMOs to any negative health impact. That's it on the health bit. The point about the terminator gene, there's a history to that. And again, it goes back to the point that I make about Monsanto and the kind of reputation that they've built over the years. Monsanto did a trial trying to make use of that terminator gene technology to then avoid a situation where some of these seeds can then not be replanted as a way to kind of protect their patents.
Right.
They started it as a trial. It got a lot of public backlash. They never commercialized any terminator gene technology inherent crop as far as what they eventually churned out are concerned. So unfortunately, that remains a huge form of disinformation that people continue to follow.
I can understand how something like that could be held against the company. But then the other thing I was wondering about was the other sort of story that I remember was the one about contamination of other crops by genetically modified crops. Do you have any insight on that particular allegation?
So that is wholly possible. But the reality is that such contamination happened not only with GMOs, but also with non-GM varieties.
Right.
So then the point is, let's say you have corn that has a wild relative, and using conventional methods, a corn has been improved upon to then be herbicide resistant.
Mm-hmm.
It is wholly possible that those non-GM corn varieties that are herbicide resistant could then have a situation where that trait of herbicide resistance could move from the corn variety into the wild species in the forest, thereby contaminating the wild species. So the point I make is the contamination is wholly possible, but it's one of those things that is not exactly restricted to just GMOs. It could happen in GM crops and happen in non-GM crops as well.
Right. And I guess also, if that were to happen, it could only happen between very closely related plants, right? So, for example, GM corn might be able to, I mean, I'm using the word contaminate in inverted commas, right? But, a GM corn could maybe contaminate other corn, but it could not contaminate, a tree species, for example, or something like that.
Precisely the point. So it can only happen under such circumstances,
right,
with closely related species. Usually the impression is created that when you have a GM crop out there in the environment, then one way or the other, everything else in terms of plants are at risk.
Right.
There are additional concerns about how, for example, there's the conversation around the chestnut trees in the US, because then they've developed a GM variety that's resistant to a very dangerous pathogen. And the main concern about possibly releasing that into the wild is how that may then result in a situation where even natural varieties of the crop may be non-existent. These are real concerns. And so in my studies, as far as the subject is concerned, then we advocate interdisciplinary conversations around some of these improved technologies, looking at the possible environmental impact, the socioeconomic impact, and all the additional related areas. But I get a sense sometimes bits and pieces of realities may then be overhyped to then create the impression it's a broad challenge, and that then get used to bastardize GMOs to a certain extent, which is sometimes not exactly the case. So at this point with contamination, and I'm also using contamination in inverted commas, they could happen in closely related species, whether it's GM crops you are dealing with or non-GM crops that you are dealing with.
Right. I think it was good to just kind of, lay out the facts there as the basis of this discussion, because the main thing I really wanted to talk about was, the relationship between GMOs and biodiversity. You've written a couple of articles on this, which I found very interesting. But can you, again, just kind of give a bit of an overview of how GMOs can help biodiversity? There are a couple of ways that you've outlined. And I think to most people, that sounds counterintuitive.
So in a number of ways, for example, I don't know of a specific GMO crop currently that has been engineered to then increase yield. But I know of GMO crops that have been engineered so that then they are resistant to pest attacks. And that then creates a situation where the farmers then have improved yield. And what that means is then that the communities don't have to destroy more land to then make way for more production. And for me, that's one of the ways that biodiversity gets protected, because I've spent quite some time in Nigeria, for example, where just about 2 years ago, GM cowpea or beans got approved. And the farmers testified to situations where they are seeing more yield on their cowpea fields, because then the GM cowpea variety is resistant to what is called the Maruca pod borer pest, which could be very destructive. Sometimes it could wipe off the entire cowpea field as far as what farmers grow are concerned. And once far less of their crops are being destroyed by pests, then they are encouraged to then plant far less fields, and that to a certain extent help conserve the environment. So that's point number one. The second point, and again, I'll use the example of the GMO cowpea, and cowpea is a protein-rich diet that's common in large parts of Africa. We have situations where these Maruca pests that I refer to, they are so destructive of farm fields that the cowpea plant takes 12 weeks to grow. That's 3 months. Over the 12-week period, on the average, farmers need to spray chemicals between 8 and 12 times to protect the farm fields from the attack by the Maruca pests. So almost on weekly basis, the regular farmer who's planted cowpea needs to use pesticides to control the cowpea. And then they end up killing beneficial insects. They end up destroying other living organisms that are existent in the soil and in the ecosystem.
Right.
But with the GM cowpea that farmers in Nigeria are currently growing, instead of between the 8 and 12 times that the farmers need to spray in the 12-week life cycle of the cowpea plant, the farmers only spray 2 times. So that's almost like an 80 to 90% reduction in the use of pesticides to control the Maruca. And again, for me, this is another way of helping preserve biodiversity because all these beneficial insects are not exactly being killed.
Right.
So I think there's a role that GMO technology can play as far as helping protect biodiversity is concerned.
Right. And I think it also, it has to be noted here also the incredible saving in cost that would be to the farmer as well, right? I mean, pesticide is presumably not so cheap. And being able to reduce the use of it by 80 or 90% is going to make a big difference to especially, the less wealthy farmers out there.
And in this case, the farmers specifically testified to that in interactions that I had with them back in August last year when I visited Nigeria, about how, in terms of how much they make from each acre of cowpea fields, a lot of them have seen the doubling of their profits, allowing them to have a lot more money to then take their children to school, take care of their health, and support their families generally. So we've seen that bit with the economic benefits. We've seen that bit with the environmental benefits as far as avoiding releasing a lot more chemicals into the atmosphere. And then we've also seen the benefit of that with averting pesticide poisoning in some of those communities I visited in Nigeria, because then we see situations where the fields get sprayed repeatedly with pesticides to the extent that even in the final week of harvest, just a day or two before harvest, the farmers are spraying their fields because they need to destroy the pest. Then by the time the harvesting is done, the chemical residues are huge in the cowpea. They get cooked, they get consumed. Then it causes all these tummy upset for children and all of that. That is also being averted by virtue of the fact that these are GMO cowpea crops that they are growing, specifically what is described as the BT. And BT is, it's a bacteria, the Bacillus thuringiensis, which then has that resistance to these pests that have been then isolated from the bacteria and introduced into the cowpea.
And that BT, that's quite a familiar sort of acronym or abbreviation that's used in various different crops, right?
That's correct. So then beyond cowpea, then we have BT corn, which is also resistant to the very damaging stem borer pests that actually attack corn. It's been used in cowpea as well. Again, the borer attacks, it's been used in cotton. I meant cotton. We've mentioned cowpea already, cotton. Again, I was in Burkina Faso, for example, where they commercialized BT cotton. If my memory serves me right, about a little over a decade ago, eventually was phased out because then there were some challenges with the BT cotton varieties. But when I visited Burkina Faso about 4 or 5 years ago, the farmers testified to how their BT cotton had also created situations where there was very much reduced use of pesticides on the farm field. So yes, that has been explored in different plants. In Bangladesh, the BT has been used in the eggplants, which is a very popular vegetable in that part of the world, where again they were seeing vast destructions by pests of the eggplant until the introduction of the BT eggplant varieties, which gradually are becoming popular in various parts of Bangladesh.
So, it's quite incredible. This sounds like, one of these miracle cures. And yet in Africa and other parts of the world, but I think maybe especially Africa, correct me if I'm wrong, the uptake of GMOs like BT crops has been pretty slow. So why is that? I mean, why is it being used in some parts of the world, but not in Africa so much? And is that changing a lot now? Is now kind of the tipping point?
So, first of all, I will be hesitant about describing it as a miracle technology of any sort.
Mm-hmm.
Because the reality is that there are vast other challenges with agricultural production that the GM technology has not been able to find ways to help fix.
Right,
So,
right.
it's a very targeted technology, and usually what is encouraged is it should most of the times be seen as the last resort of a sort. If there's a way of improving upon your corn to then be resistant to a particular pest using conventional plant breeding methods, why would you want to use more enhanced technology to a certain extent? Except that the reality is it helps shorten the amount of time that some of said breeding procedures take. In a lot of places, it seems to be more efficient when it comes to improving crops. But then just making the point that it's a very targeted technology. It's not like a one size fits all.
Yeah,
As far as
it's kind of, and sort of sorry to interrupt you, but it's kind of targeted at particular challenges, right? Like if there's a particular agriculture, and one other one that I've heard about is I don't remember the crop, but drought resistance. So in areas where drought is a problem, a drought-resistant crop is going to be really useful, obviously.
Precisely. So that's been done in corn as well. There is a variety of corn. They call it the teller maize, which is being developed in certain areas in Eastern Africa, which has that drought resistance traits.
Right.
And it's been used in other spheres as well. The technology has been used to improve upon rice, to then develop what is called the golden rice with more vitamin A precursor content, to then ensure that its consumption then gives the consumers more vitamin A.
Right.
But that has been worked on in the Philippines, but hasn't been commercialized yet, and it's not yet out there on the market. So that's actually the point, that is very much targeted.
Right.
To your point about how come it's used in Africa, has been to a very large extent very slow. That has been mainly due to a number of issues that I think goes beyond the technology itself. So this is a technology that the Americans developed, and the Americans made a lot of progress with it for many years before then it got popular in other parts of the world, including in Europe. My reading of it has been that Europe has been hesitant to its adoption, mainly for economic reasons, because then the Americans have made quite some progress with it. So then if there is a way to then kind of encourage the use of available technologies, because then allowing this into the space then creates some advantage for the Americans. I get the sense those economic reasons tend to influence a lot of why the Europeans have been slow in adopting GMOs. And so in the US, for example, currently, more than 90% of corn is GMO, more than 90% of cotton is GMO, and then crops like soybean, more than 90% of them are GMO. So then competition appears to be the reason why Europe, for example, tends to avoid that. And then Africa then tends to fall in the middle of that. The Africans see the Europeans as very close, and that's where a lot of African crops that get exported then land at. And if the Europeans are hesitant with adopting GMOs, then the Africans are asking themselves, what will be the implication for us if we adopt it? I get the sense that's one of the reasons why the adoption of the technology in Africa has been very slow, because then the Europeans, through their non-governmental organizations or general trade policies, are discouraging Africans. And the Africans are very much tied to the Europeans economic-wise and agriculture-wise. And then not just that, the whole conversation around ensuring the safety of GMOs started as an environmental conversation. So then the Convention on Biodiversity and related conversations at the United Nations level then ended up drawing the regulations around GMOs generally. So then the Cartagena protocol came into force and all. And all of these protocols have then created very rigorous, very detailed, in some cases, unnecessary regulations which then govern how GM crops get released. And those processes have become cumbersome, expensive, and it's only the big industry that then are able to then appropriately get them from trials all the way to commercialization. And to a certain extent, that has very much hindered its adoption in Africa. And the disinformation campaign that I referenced earlier then has created a certain fear situation where people in Africa then fear that all the misinformation around it causing diseases and all may be true. So then the governments are hesitant about their adoption to a certain extent. I think those are some of the reasons that have discouraged the adoption of the technology in Africa.
Right. And do you think that's changing now? Do you think that the proponents of GM, I've read some of your accounts of academics in Ghana who are trying to reach wide audiences to tell them that, this is really something that should be embraced where appropriate. Are they achieving success in that message that they're sending?
I think a lot of the point you drew attention to in terms of people in Africa being hesitant, that is changing over the last few years. I've had the opportunity to visit different places across Africa, Burkina Faso, Nigeria, Mozambique, Kenya, Uganda, to interact with scientists working with some of these biotechnology and GMO tools to improve upon crops. And now I see more of scientists who've been trained in the technology taking time off to step out there, engage farmers, interact with them, explain the technology to them, get on radio, get on TV, explain the technology to them, to then create a situation where people understand what it's all about and then defeat the misinformation and the disinformation and the fear around the technology. And as I mentioned, right here in Ghana, I studied a course for a BSc that's focused almost entirely on GMOs at the Kwame Nkrumah University of Science and Technology in Ghana. So a lot more people are embracing the idea of using some of these innovative tools to then do things differently. But mind you, South Africa was one of the very first countries to introduce GMOs. I think after it was introduced and the first GMO crop went into the market in the US in 1995, almost about 2 years later, GMOs were introduced in South Africa with corn and cotton and related varieties. And if you look at the figures, it's similar to what exists in America, whether it's corn or cotton, soy. More than 90% of these crops in South Africa are genetically modified crops. So unfortunately, beyond South Africa, the technology didn't extend to large parts of Africa. But in the last decade or so, then we've seen all these countries that I've mentioned then getting involved and things changing. We're seeing changing mindset. There's more available information. The scientists are stepping up in terms of communicating what this technology is all about as well. And that is making a huge difference, I think.
And are there lots of local scientists involved as well? I mean, are these scientists Ghanaian scientists in Ghana and Kenyan scientists in Kenya, or is there a lot of expertise coming in from elsewhere?
I won't deny that some level of knowledge, expertise is coming in from elsewhere, because then there are some of them who are American trained, people who work with other international institutions working on GMOs, and that's where they got their knowledge from. But if I'm not mistaken, in terms of the GMO work that's being done in Africa, at least from my interactions, more than 95% of those developing these crops and shepherding their approvals and all are African scientists in these countries that I've mentioned.
And do you think that the gradual success that seems to be happening now with GMOs, do you think it's partly a result of people just kind of seeing GMOs in action and that knowledge just gradually spreading? Or do you think there are particular events or particular, I'm not sure, maybe particular varieties that, make real waves? Why do you think that it's now having success? Or is it just the result of a very gradual and incremental improvement over, since the 1990s?
Well, a number of things are happening. First of all, developmental institutions, whether it's non-governmental organizations, civil society groups, international firms working to help improve upon agriculture
Mm-hmm.
are then seeing the potential of the technology and its possible use in the developing world to then deal with food insecurity challenges. So there's a lot more political support for it, both locally in the various African countries and internationally as well.
Mm-hmm.
Additionally, those opportunities are also being provided for countries that have used some of these technologies to then open up their doors for people from other parts of the world to come see.
Mm-hmm.
I know of scientists from Ghana who've been in places like South Africa and Nigeria to go see the kind of work that is being done. And that is, to a certain extent, motivating them to want to replicate same in their various countries. All of those are combining to then see a situation where a lot of these technologies are being embraced. So people seeing the technology in action in their own countries or in their neighboring countries is making quite a difference as far as the spread of these technologies are concerned. But I think the larger thing has been that we live in a more advanced world today where the ordinary farmer is able to get access of the internet, be able to probably do a Google search of what GMOs are after listening to a scientist come tell him about it and be able to read about it and understand. We live in a world where information is more abundant today than ever. Radio stations are making conversations around GMOs in Africa, topical issues for conversations. And so people are listening to these conversations and properly understanding it and shedding of the fear. I think a lot of that is what is making the huge difference and encouraging its acceptance generally.
Right. Do you think, are there still sort of major obstacles to the acceptance of GMOs, especially in Africa, but also in other parts of the world? Or do you think it's just, it's just a case of keep on going and keep on talking?
Well, I may be wrong, but I think the prospects actually look good for the technology in terms of how people are seeing it and challenges with food security challenges and people seeing this as a tool, not the miracle cure, but as one of the tools that could help deal with some of these challenges. I get the sense in that regard, the prospects actually look good. When the use of the technology then began, then there was a lot of focus on industrial crops, if I could call them so, whether it's corn, whether it's cotton, whether it's soy, because then you produce these crops and send them across the world, and people made money from these crops. So then the technology was applied as far as these crops are concerned.
Sorry to interrupt you again, but you're talking about kind of large-scale commercial operations, right?
That's the word that I was actually looking for. So that was kind of the focus with the application of the GM technology. But over the last decade or so plus, we've seen a change of a sort in that. We've seen the expanded application of the technology beyond the large-scale crops like corn and cotton, and we are now seeing its application in what you could describe as orphan or neglected crops like cowpea, and even in vegetables like the eggplant in places like Bangladesh. So for me, that further raises the prospect. The technology was again used to deal with the ring spot virus when it comes to papaya in the US, I think about 15, 20 years ago, and helped save the whole papaya industry in the Hawaii area in the US. So then we're seeing all these different applications, which then give all of us the sense that just maybe there is more that the technology would be capable of doing.
Right.
But then I think also that major bottlenecks do remain. We are seeing Africa opening up a bit more to the technology. We've seen discussions about the technology in places like Europe, which would eventually also have a huge consequence on the position that Africa takes eventually. Those are all things that attention needs to be paid to in terms of what the possible impact of it will be. The disinformation campaign doesn't appear to be ending anytime soon. Population per specific rates when it comes to some of these concerns that have been raised about GMOs, about it causing diseases. Some of those statistics show that it's worse in places like Europe than it is in places like America. But still, the disinformation campaign continues. So that also remains a major threat to further adoption of the technology. We can only wait and see, but I still think that the prospects are very much high as far as the likelihood of more adoption of the technology is concerned in Africa and other parts of the developing world.
Right. Yeah, it's interesting though what you said about Europe, though, because my perception is that at a global scale, most of the resistance to GMOs is coming from Europe, and certain countries in particular. Some of the wealthier European countries that don't necessarily need to worry about food security. And I guess that while Africa doesn't necessarily need to wait for Europe to approve them, it would certainly help a lot if there was a wider European support for it.
Well, what we've seen in Europe is countries like the UK, after they exited the European Union, are now taking steps to refashion their own laws governing GMOs and gene editing and painting it in a more positive light and appearing to embrace it a bit more.
Mm-hmm.
We wait to see how that may end up shaping the rest of Europe as far as the possible adoption of some of these technologies are concerned.
Interesting.
There's also a bit of the disinformation, not a bit, but a large chunk that's coming from even the United States itself, where there are all of these non-GMO projects, and even for substances like salt, where there are no GMO varieties, then they roll out anti-GMO campaigns that then say they have non-GMO projects that's trying to discourage people from consuming GMOs. All of that is happening, particularly in the United States and to a very large extent in the European Union. I think that the main difference has been the kind of regulation, where in the European Union, then there's overly precautionary approach and heavier regulation of the specific varieties, which then creates a problem. So yes, you are right. Africa needs to fashion its own path, decide how they would want to approach it. Sometime in 2018, then developing countries then outpaced the developed world in terms of the growing of GMOs.
Oh, really?
Yes. So an organization called ISA then publishes details every year on the amounts of GM crops that are grown across the world on an annual basis. And from the statistics back in 2018 or so, then we had a situation where majority of the GM crops were being grown in the developing world. That again gives a certain hope that the developing countries are embracing some of these technologies. And that's how come I see a situation where the prospects look a lot brighter than them as far as further adoption of some of these GM crops are concerned.
You're mentioning resistance in the US. I'm wondering, with the level of political polarization, I think globally, but especially in the US at the moment, it seems like every issue is polarizing. And GMOs, I guess, is one of those issues as well. It's kind of like if you support a certain party, then you'll be for them. And if you support the other party, then you're expected to be against them.
I don't get that sense. I'm not super familiar with the terrain in the United States, but I don't get the sense that the GMO conversation particularly has become politicized.
Right. Okay.
We know that has happened to a certain extent with COVID-19 vaccines and believe in COVID-19. Usually we would put a lot of these in the sphere of what are described as controversial scientific technologies, which then probably gives a sense that when you dig a bit deeper, you may find a situation where that may well be playing a role. But I don't get the sense that that is what is happening in the United States of America.
Right.
In Africa, we are seeing a bit of that in terms of the politicization. In Ghana in particular, one of the political parties, not the major ones, but the Convention People's Party, which was founded by Ghana's first president, Dr. Kwame Nkrumah, was a party to one of the major court cases in Ghana that then aimed at pulling brakes on the adoption of GMOs in Ghana, because then they thought that the processes were illegal, and the Convention People's Party had been involved in one of the court actions that was led by another civil society group, the Food Sovereignty Ghana, to then stop the introduction of GMOs into the country.
Right.
So along that line, then you see the political bit of it playing out. But I don't get the sense that it's very much of a big deal. Again, especially when we see more adoption in the developing world. Just to go back briefly to the statistics that I was mentioning, as at 2019, when it comes to the growing of GM crops globally, 56% of all GM crops were grown in the developing world, and then only 44% was actually grown in the developed world or the industrial countries, which then speaks to the point about how more developing countries are adopting it. But whether in the developed world or in the developing world, I'm unable to speak much when it comes to the industrial nations. But I get the sense the politicization along political party lines doesn't appear to be playing so much of a role in terms of it fueling resistance or anything like that. Okay,
well, that's a good thing, I guess. Yeah, and then the last thing I was just wondering, as we're speaking, you mentioned the Cartagena protocol. So that's basically a protocol which is trying to kind of exercise caution with regard to GMOs and their effect on biodiversity. Is that a correct understanding of what that's about?
That's exactly a summary of it. It's a protocol that got introduced to then say, as part of measures to ensure that GMOs don't harm the environment, countries seeking to introduce GMOs that sign onto this protocol would have to go through some specific procedures before placing the GM crops on the market. So then, for example, then the protocol requires that countries should have laws governing GMOs specifically. So then the laws need to be put together. A specific institution, in Ghana's case, an authority, the National Biosafety Authority, has to be set up in any country that would want to adopt GMOs to then oversee the approval processes. There needs to be what they call trials over a duration. Before you begin the approval processes for GMOs, you need to apply to this said authority for permits to then undertake trials. And once that is done, you need to go back to the authority for permits to then release the crop into the environment. And so then it ended up spelling out procedures to allow for the introduction of GMOs, which don't exist as far as conventionally bred or conventionally improved crops are concerned. Although some of those other technologies that are used in improving crops are sometimes more dangerous than genetic modification. So, for example, when you use radiation technologies to then improve upon crops by passing the rays through the seeds to then mute certain specific parts for certain specific effects. When you look at it, some of those technologies are kind of a bit more dangerous than genetic modification, but there is no such cumbersome regulation that then governs how some of those crops then get to the market, like the cumbersome procedures exist as far as GMOs are concerned. So that's essentially what the Cartagena Protocol is all about, encouraging the precautionary approach. I'm, for example, very critical of the whole protocol and the approach to it. But my country, several other countries have signed on to it. We just probably have to live with it.
I wonder if it's something which could be tweaked and refined to make it better, or do you think without it, the world would be a better place? Or do you think it's more a case of something which could be just improved to make it less cumbersome?
I think improving upon it to make it a bit less cumbersome would probably be a better idea in terms of what the approach should actually be. Except that I've paid attention to various conversations at the CBD, the Convention on Biodiversity, and looks like there's been very conscious efforts by various environmental groups to then make it even more severe and more cumbersome in terms of the suggested alterations to some of the regulations and all these protocols. But on a regular day, I wouldn't advocate a situation where there is no regulation at all. But I think the regulations need to be fair. They need to be less cumbersome. And the approach to it should be a bit more forward-looking than backward-looking. the whole biodiversity conversation around GMOs need a bit of redirection, where then we're asking the question, I think, how can GMOs play a role in helping improve upon biodiversity, rather than approaching the conversation and the suggested reforms in a way that say GMOs don't help biodiversity, so let's pull brakes on it, contrary to the evidence and some of the examples that I've cited that GMOs actually have a role to play in helping protect the environment. That's the kind of approach I would encourage.
Okay, next time I'll be speaking with Eric Sanderson, a landscape ecologist for the Wildlife Conservation Society at the Bronx Zoo and author of the book Manhattan, A Natural History of New York City. Cities have been covered before on this podcast, particularly in episode 6 with Deborah Roberts. But this discussion is based on the seemingly radical notion that cities will help to save biodiversity worldwide. It's based on a paper that Eric and co-authors published in Bioscience in 2018. This discussion could change the way that you see cities, so I hope you can listen in.